Hello, friends. Today I'm going to talk about architecture, primarily either it is mobile app or web browser app. It is very important that we are able to scale that architecture for large number of users. Let us understand the journey, how this architecture evolved. Uh, Primarily, when anybody start the application development, they start with a small number of users, and then as business grows, they eventually make it a for large number of users. So let's talk about the very simple case where, as you can see in my screen, where you have developed a web browser, either it is HTML page or mobile app. In case of Java-based, Android-based mobile app, where user will interact through the web or mobile app. And then, of course, the request has to come from the particular machines, and that has to be mapped with the particular domain names. And then that request will redirect to the server, which you have posted your application in a web server. And of course, once the request is sent back, the front end guy, or the user, will able to see the content what he has requested for. So in this architecture, there is a genuine problem, right? If web server can be crashed, then it will be a nightmare for any technical people, or for the front end guy, it will be very bad user experience because he will not able to see the data. And similarly, it is not scalable because all the applications database is in the one web server. Similarly, there is no segregations of data. There is no segregation of business layer. Yeah, so and so on and so forth. So eventually, it is not an scalable architectures. And if you are not able to scale it, then probably you are not able to meet your business requirement, business growth, because this is how today in enterprise and digital world, you need to think about futuristic design, where user base can grow, your business can grow, user base can grow, and obviously you will able to support your application should support those increased number of users. In that case, probably you need to think about slightly bigger architecture where I'm talking about here. So request comes from the front end, and then of course you need uh, a load balancer to redirect your request to a certain server. If one server is down, probably other servers should be able to respond to the browser. So your request directly the front end side don't have to communicate from the web browser does not directly communicate to the server. It communicates to the load balancer. Load balancer IP address will be given to the front end to integrate, right? Or load balancer URL will be given to the front end to integrate. So when requests come from the web browser, it first comes to the load balancer. So load balancer will check the availability of the server and accordingly redirect to the right server. And then once response come, it goes through the load balancer and back to the browser. So in that case, what is the benefit? Benefit is, of course, if web server is down, one web server is down, other web server will be able to respond back, and then overall application will be high availability. Right? So that is the primary advantage. Right? Of course, the cost will come, but that you have to trade off. Similarly, now your application is here but then you wanted to decouple your application front end code with the database code, so that if some of the authentications of user or some of the persistence of data into database server, so that applications will be data will be segregated, so that the data is situated in the front end can be again decoupled into a separate database, where you can see here master and slab. So master database will get the direct requests, and if any kind of failover required, and then it says slab database will also have a another copy of the master database. And therefore, in this architecture where database, if large number of data volume grows, and then for certain region database server crashes, then still you have a copy of the data. And similarly, there is a cache. So all the request that comes from the server, sometime if it is a very much business specific or it require a lot of processing logic, then some of the data can be put in the cache. Then still the requests can be given instantly rather than taking long time. So that is how this overall architecture where database server has been decoupled, web server has been distributed so that the requests can be served even though one or two of the web server is down. Similarly, database is it is a kind of a horizontally scaling where if one database server is down, then still you have a copy of the data so that your application will remain safe and secure. Similarly, if there is a business processing logic which takes a lot of time, then you have a cache to send the response back, and then make applications working for those scenarios where there is a huge amount of processing logic is required. And CDN server that you can see here, some of the HTML and images can be put in your nearest CDN server so that the loading time will be faster and better. So this is somehow slightly better architecture than what we have seen earlier. This will definitely able to take the load of large number of users and help your business to grow and survive. So I hope I'm able to explain at high level overall the scalable architecture for large number of users. So let me stop for today and we'll connect again in the next video.